In this video, we are going to discuss about basics of three-phase circuit and associated terminologies. First of all, let's see what is the difference between single-phase circuit or single-phase system and three-phase system. A single-phase system is a system which generates single-phase alternating voltage. That is, single-phase system utilizes only one winding. If a system generates three-phase alternating voltages, then that system is a three-phase system. That is, three-phase system utilizes three set of windings. Similar way, we can have n-phase system also. In n-phase system, n-phase alternating voltages are there. This system contains n number of identical windings. As seen here, a single-phase system contains only one winding, say 1 which is rotating at a speed omega radian per second, say in anti-clockwise direction, under the influence of the uniform magnetic field which is created by North Pole and South Pole as shown here. Based on electromagnetic induction, whenever flux linked with the conductor changes, here, due to relative motion between stationary magnetic field and rotating conductor, an EMF is induced in this conductor. This voltage is of alternating nature as shown here. At 0 degree, voltage magnitude is 0 volt. At 90 degree, voltage magnitude attains peak value. And at 180 degree, again voltage magnitude becomes 0. And at 270 degree, voltage magnitude become negative maximum, and at 360 degree, again its value become 0. This type of voltage waveform is alternating voltages. The instantaneous value of generated voltage can be expressed in single-phase system as E is equal to Em sin theta, which is equal to Em sin omega t, where Em is maximum value of induced EMF in this winding. Similar way, when we are considering three-phase system, a three-phase system can be considered as three separate single-phase system with a phase displacement of 120 degree electrical or 2 pi by 3 radian. That is, a three-phase system consists of three separate but identical windings displaced by 120 degree electrical or 2 pi by 3 radian from each other as shown here. Here R dash is one winding with R indicate starting of R phase winding and R dash indicate finishing of R phase winding. Similar way, Y dash indicates starting of Y phase winding and Y dash indicate finishing of Y phase winding. Similarly, B is starting of B phase winding and B dash is finishing of B phase winding. Here it can be seen that Y phase will start 120 degree after the starting of R phase. Similarly, B phase will start 120 degree after the starting of Y phase or 240 degree after the starting of R phase. Thus, a three-phase system consists of three separate identical windings displaced by 120 degree electrical from each other. When these windings are rotated in anti-clockwise direction with constant angular velocity in a uniform magnetic field, an EMF is induced in each winding which have equal magnitude and frequency but are displaced from each other by 120 degree electrical. The instantaneous value of EMF induced in R phase, Y phase and B phase can be expressed as ER is equal to Em sin omega t, that is Em sin theta. EY is equal to Em sin omega t minus 120 degree, that is Em sin theta minus 120 degree. And finally, EB is equal to Em sin omega t minus 240 degree, which is equal to Em sine theta minus 240 degree or Em sine theta plus 120 degree, where Em is the peak value of induced EMF in each winding. This is the voltage waveform in three-phase system. Here voltage in R phase is 0 volt at 0 degree and it attains peak value at theta is equal to 90 degree. Then again it becomes 0 at theta is equal to 180 degree and it goes to negative direction. Similar way, the Y phase voltage start from 0 volt after 120 degree from start of R phase. That is, the distance between this point and this point is 120 degree. Then after starting of Y phase voltage from 0 degree, it will attain maximum at 90 degree with respect to this starting point. So Y phase attain its positive peak at 120 degree plus 90 degree, that is at 210. So this point is at 210 degree. Similar way, B phase voltage will start from 0 volt, that is at this point, after 240 degree from starting of R phase or 120 degree from starting of Y phase. And this B phase voltage attain peak value at this point is 240 degree. So this point occur, that is peak value occur 240 plus 90, that is at 330 degree. So here we can see that the order in which voltage in three phases attains the maximum positive value is in the order R, Y and B. This order is known as phase order or phase sequence. That is, the order in which voltages in three phases attains maximum positive value is termed as phase sequence. In this waveform, the phase sequence is RYB. This is the Phasor diagram of three voltages induced in three identical windings, that is three phases. As the windings are identical, the magnitude of induced EMF in each windings are equal. Here, the magnitude of each phases are equal. But these voltages are phase displaced each other by 120 degree as shown here. ER represents voltage phasor in R phase. EY is voltage phasor in Y phase, which is 120 degree clockwise with respect to R phase, that is ER. And voltage phasor EB is 240 degree clockwise with respect to ER or 120 degree anti-clockwise direction with respect to ER. Now let's see advantages of three-phase system. The first point is, in single-phase system, the instantaneous power is fluctuating in nature. However, in three-phase system, it is constant all time. That is, although power supplied by each winding in three-phase system is fluctuating or pulsating, the total power supplied to a balanced three-phase circuit is constant in three-phase system at all time. Then second point is, the output of three-phase system is greater than that of single-phase system. Next point is, transmission and distribution of three-phase system is cheaper compared to single-phase system. Next point is, three-phase motors are more efficient and have higher power factor than single-phase motors of same frequency. If power factor is less, it will take more current, thereby losses will increase. If power factor is higher, that is near to unity, then motors will take less current, therefore losses will decrease. Then next point is, three-phase motors are self-starting, whereas single-phase motors are not self-starting. So considering all these points, we can say that operating characteristics of a three-phase apparatus are superior than that of similar single-phase apparatus. Next, let's see some important terms which is coming in three-phase system. The first one is phase sequence or phase order. The sequence in which voltages in three phases reaches the maximum positive value is called phase sequence or phase order. From Phasor diagram, it is clear that voltage in coil R attains maximum positive value first, next in coil Y, and then in coil B. Thus, phase sequence is RYB. Next term is phase voltage. Voltage induced in each winding is called phase voltage. It is represented by V phase. Next term is phase current. Current flowing through each winding is called phase current, IPH. Next term is line voltage. Voltage available between any pair of terminal is called line voltage. Similarly, line current. Current flowing through each line is termed as line current. Next terminology is balanced or symmetrical circuit or balanced or symmetrical system. If voltages in the three phases are equal in magnitude and differ in phase from one another by 120 degree, and similar way current in the three phases are equal in magnitude and differ in phase from one another by 120 degree, then that circuit or system is termed as balanced system or symmetrical system. Similarly, we can have balanced load. If load connected across the three phases are identical, that is, all loads have same magnitude and power factor, then that load is said to be balanced load.